All right, hello, welcome back, and thanks for joining me for a minute. Let's take a look at a couple of questions on the test review for quadratics. Um, so yeah, let's just jump right on in there. So I'm just going to look at problems 3 and 4 off of the review. Let's just take a look at, in the first one, how do we take an equation and turn it into both data that fills out a chart as well as a graph? And then how do we go the other direction? How do we take that data and discern what that equation would be? So a couple of things to be aware of. First off is remember, we want to know what A is, what B is, and what C is. And so keep in mind, A is the coefficient in front of x squared. And remember, it's not the x squared, but it's the number in front of that x squared. B is the value in front of the x, and C is the constant at the end, which incidentally is also the y-intercept. So keep in mind, since we already have the y-intercept just by writing that down, I could come down here and put a dot at the coordinate 0, 7, because I already know that this value 0, 7 is C. Now, you don't have to write C there, but I'm just making sure everybody understands that. Now, we learned a little formula that said the line of symmetry, and some people called it an axis of symmetry, but it's the same thing, is always a vertical line, x equals opposite b, over 2a, and the opposite of 4, of course, is -4. And if I double -2, I get -4, and I got 1. So that means my line of symmetry is at x equals 1. So what I like to do is in my table, I like to center my table at that value 1. And we can jump down in here to my graph, and I can put a dotted line at the number 1. So here is my line of symmetry that I found here at the number 1. And I'm going to find out that I think I regretted where I specifically wrote that 9, 7, but hopefully that'll work out okay. So the next thing we want to do is we now know where that line of symmetry is, but we really need to find out specifically where the vertex is. So what we're going to do is we're going to take this original equation, and every single place where I see an x, I'm going to replace that value with a parentheses. And in that parentheses, I'm going to put in the number 1. And I know that, 4 times 1 is 4. That's easy. 1 squared. Now keep in mind, in order of operations, we know that the exponent happens before your multiply and divide. And of course, add and subtract comes last. So if I took the 1 and I squared it, I got 1. So I got -2 plus 4 plus 7, which is a total of 9. That's why I said I think I was going to regret the positioning of that. So I might use a little bit of whiteout to get rid of some of my note right here. But I know that at the number 1, I got 9. So 5, 6, 7, 8, it's about right there. So when I plugged in 1, I got the number 9. And of course, over here, at 0, we had 7, which was our C value. I'm just going to go ahead and put that right there. So that's what we've got. And so the next little phase of my story is we should go ahead and count values that are centered around this number 1, 9. So remember, this is my line of symmetry. So every value on both sides has to match. So 2 and 0 will match, 3 and -1 will match, and 4 and -2 will match. So let's see what we can do. Now, we could, if we wanted to, repeat the process that we did right here, and we could plug in the number 2. See, we could plug in a 2 here and here. But there's a faster way of doing that. And that is if we remember our 1, 3, 5 pattern. So remember, we have this 1, 3, 5, 7 pattern that we have learned, and we have done a lot with it. And it goes on forever. Keep in mind, these do. But because my A value is -2, that is going to get multiplied by -2. So what's going to happen is if I go over, I'm going to move down exactly 2. And then If I multiply by -2, now I'm going to go down 6. And then if I multiply, I'm going to go down 10. And all of a sudden, we have plenty of information to come up with a nice graph. So keep in mind, I went down 2, then down 6, and then down 10. So I dropped 2 from here, dropped an additional 6 and an additional 10. So if we did that, here's my down 2. Then we're going to go down 1, 2, 3, 4, 5, 6. And using the symmetry, I got nice easy values. And then I'm going to go down 10, which is an awful long way to drop, but I know that it's at -9, so it'd be right in here. And so I can do that. Now, I'm having something happen in my classes this year that I have not seen in the past, which is a lot of people wanting to stop right there. Please don't stop right there. You want to do one more thing, and that is to connect the dots and make a nice smooth shape known as a parabola. Remember, they're never sharp. They don't look like a V. They look kind of like a U shape. And so that's a good way to start. Now, one thing that is important when you're studying and you want to gain that confidence to make sure that all of the math that you're doing is correct, it's a good idea sometimes to go in there and just double check ourselves. So what we could do while we're studying, again, this doesn't do anything for the test, but when you're learning the math and you want to make sure that you are doing things right, let's go ahead and take a look at Desmos for a second, because this is not a bad idea. So I'm going to type in the question that I have, which is y equals -2x squared. Let's see, plus 4x plus 7. And the first thing that I would want to know is, does this look like what I have? But unfortunately, it doesn't look quite right because my x and y's should have steps by 1. So it looks more like what we have. And if you look at this graph does now look pretty much like what we did on paper. But there's another little thing that we could do that might be kind of smart. We could go into here, and instead of calling it y, if I call it f of x, now I can add a table. Now their tables by default, I'm going to call the first column x and the second one f of x. Their default table is a vertical table, but I could try the values that I did on mine and see how it works. See, if I tried -2, -1, 0, 1, 2, 3, 4, I can very, very quickly confirm that the table that I generated from that equation works. And I had to name it as f of x so that my computer would understand, so that Desmos would understand how to make this particular table. I can't just call it y because I have to refer to this equation. So that's a good way to confirm what we have. Now, before I go on to the next problem, I'm going to turn this thing off. And I'm going to try something, because when I do my problem on the next one, I want these numbers right here to turn into the values on that question. So I'm going to go ahead and delete my function right here. And when the next one, we're going to type that in, and we're going to make sure that that data actually matches the graph that we have. So let's go back to that. So off we go back to this. Now, of course, we are now going to be taking a data table and trying to figure out how to generate what we have. Well, there's a few things to know. I want to find out what A is. I want to find out what B is, and I want to find out what C is. And there's A and C are both very, very easy, because C is just what happens when you plug in 0 for X. So if we look right here, I have the value of C already down. I know that C has to be the number 2. That was pretty easy. I also know that there's a 1, 3, 5 pattern that gets multiplied by that A value. So when I look for where my table is centered, which is right here, again, I'm going to go ahead and grab my line of symmetry right here. I'm going to put that one in pink. This is my LOS. Or my AOS, depending on what teacher you have. That's my line of symmetry happened at x equals 1. But I noticed that it went up 2, and then it went up 6, and then it went up 10. Now, the table could keep going. We chose not to. But I think we could tell that the number that I would have to have right here so that when I multiply 1, 3, 5, it becomes 2, 6, 10, means that our A value must be 2. All right, cool. We've got that one down. So I know that A is the number 2. I'm going to go ahead and use a little yellow on that one because I know that A is 2. So I got 2x squared. So the only thing I haven't yet figured out is what is B. So that's my last little piece. But we know what we need to have because we also have a little formula that the line of symmetry, which is x equals 1, is supposed to be opposite b over 2a. Well, we already determined that a is the number 2. So somehow the number 1, my line of symmetry, has to be the opposite of b over 4. So if I could multiply both sides of this problem by 4 or cross multiply, depending on how you want to say it, 4 would be the opposite of b, which makes b -4. And there we have our final piece of the puzzle. So b right here has to be -4. And we've got all 3 pieces of my equation. Here's f of x. Now, let's go ahead and double check to see if we did that correctly. So let's go ahead and look back at Desmos for a second. Again, this doesn't work for the day of the test, but it's just to make sure that we haven't made any mistakes as we're studying for that test. I've got 2x squared minus 4x plus 2. And here is my data table. And if you look, it matches perfectly the data table. -2 should be 18, and it is. -1 should give me 8, and it is. My y-intercept should be 0, 2. And therefore, this is what the graph is going to look like. I just now need to transfer that data onto my graph. And so I guess let's go ahead and do that real quick, and we'll be done. So here we go. We know that our data is good. We're going to put a dot here at 1, 0. That's my line of symmetry. Over 1, go up 2. Go over 1, go up 1, 2, 3, 4, 5, 6. And I could go over 1 and go up 10, but that number would be way too high on my graph, so I'm not going to bother to do that. And I'm going to make myself a nice smooth parabola. It looks like I missed that dot a little bit. Wish I got a little closer there, but pretty close. Okay. Hey, hopefully that worked out and helped you guys a little bit. And I will see you guys back in class. And hopefully that was helpful. Bye-bye.